Scalability of blockchain network is one of the biggest issues, and Ethereum is no different. Let us take a look at what kind of solutions are being attempted in this space. Gartner examines blockchain scalability as operation and technical components, each with their own set of unique problems. Operationally viable blockchains are more near-term solution, whereas Gartner claims technically scalable and programmable blockchains won't be feasible for multiple years. Gartner mentions many of the solutions that the ecosystem is currently working to develop, such as layer 2 scaling solutions, more complex smart contracts, and data confidentiality. However, they clearly believe these problems will be solved within the next decade, resulting in widespread blockchain adoption by 2030. The diagram shows what Gartner is predicting and the entire journey. The early years of this industry have seen countless products attempt to use blockchain as a technical solution to their problem. Some of these solutions have been successful, while others have run up against some of the blockchain's native limitations. Scale is the big issue, with root blockchains like Ethereum only able to process a paltry 15 to 20 transactions per second. There are other issues as well, including high gas prices and questionable privacy. Root blockchains could theoretically implement changes that solve these issues, but it would almost always come at the cost of decentralization, the main reason for using blockchain in the first place. So, how do we implement blockchain solutions for scale, privacy, and cost effectiveness without sacrificing decentralization? That's where layer 2 blockchain technology comes in. So, what is layer 2 blockchain technology? Layer 2 blockchain technology is often referred to as an off-chain solution. Its main purpose is to scale blockchain transaction capacity while retaining the decentralization benefits of a distributed protocol. Blockchain mainstream adoption will get a boost if the scalability problem is resolved. To build a good blockchain ecosystem, we need a few things in the architecture to balance the needs of security, decentralization, and scalability. Layer 2 blockchain technology systems are those that connect to, say, Ethereum and rely on Ethereum as a base layer for security and finality. In other words, rather than changing the base Ethereum, we add smart contracts on the main blockchain protocol that interacts with activities off-chain. Before we get into layer 2 solutions, is there a layer 1 solutions to scalability? Of course, yes. And that is what we learned when we covered Ethereum upgrade from version 1.0 to 2.0. All those upgrades, namely sharding, replacing proof of work with proof of stake as consensus mechanism, and replacing EVM with EWASM are changes to the base layer, and therefore they are called layer 1 solutions. The following diagram explains this clearly. Layer 1 is the base consensus layer of the Ethereum protocol. Layer 1 scaling solution increases Ethereum's transaction throughput by increasing the capacity of the base blockchain. These changes typically require a hard fork. Remember, we said that when Ethereum 2.0 becomes the mainstream protocol, Ethereum 1.0 will become one of the shards. Though layer 1 changes helps increase the throughput, it is nowhere close to what Visa and MasterCard offers, and therefore these changes will not be enough to drastically increase the mainstream adoption of blockchain. Now, back to layer 2 solutions and how do they work. Layer 2 platforms and protocols process data in a way that decreases the burden the base layer usually bears. By offloading transactions from the main chain onto layer 2 platforms, the blockchain network can handle much higher transaction throughput. And what is that layer 2 enables that layer 1 cannot? Ethereum processes roughly 15 to 20 transactions per second compared to PayPal that processes few hundred per second and Visa that process few tens of thousands per second. Why does this blockchain architecture lacks in processing? Well, remember consensus mechanism and the transaction validating process? When a transaction happens, there has to be global consensus across the decentralized network. All nodes on the network keep a full copy of the transactions to validate the transactions on the network. It is designed to solve the double spend problem without relying on a middleman. Blockchain networks can serve as the layer 1, that is the base layer of the decentralized web ecosystem. The end goal is to re-decentralize the infrastructure, protocols, applications, and various layers of the World Wide Web. Solutions are tiered. Layer 1 serves as the security layer that anchors data transaction in a way that's immutable, cryptographically secured without a central authority. Elizabeth Starks of Lightning Labs refers to blockchain as the base layer for the decentralized internet. Layer 2 allows you to massively cut down data processing on the blockchain by running computations off-chain. The base chain will still be the ultimate judge when there are disputes. You cannot move away from the layer 1 as we are in the crypto world that is managed in layer 1. The main benefit of second layer is that it minimizes the amount of data storage on the base layer. Taking transactions off the base layer while still anchored to it would free up processing resources to do other things while still getting the security and decentralization benefits.